4.3, second part here, or next page we're doing is still solving polynomial equations. And the method that we have that I showed you on the page before is that we're comparing it to 0. So that what we want to do here is that we want to set one side equal to 0. So set one side to 0. Okay? Then we can compare the line to above or below 0, right? That is the best strategy that we have to do that. So we do want to have one side equaling 0, or not equal to 0, greater than or less than or greater than 0, okay? So we want 0 on one side. It doesn't matter which side. It'll work either way. I'm just going to go ahead and move this stuff over and have the right side being 0, okay? And again, it doesn't matter which side. So we're going to grab that. Bring this over, so I'm just going to leave the x cubed here. Negative 2x squared minus 2x squared, so it'll be negative 4x squared. 5x minus 14x will be negative 9x. 20, and then that's plus 16, so plus 36, and then we've got the 0 here. Okay, so we are always looking for this 0. Okay, so beautiful 0 there. Then you have your choice in how you factor. So you can factor any way that we have from the methods that we know, right? So we can go 2 by 2 if it's possible. Don't force it. If it's not possible, you can't do 2 by 2. In this case, it does work 2 by 2. So you could do that, okay? Or factor theorem, then synthetic division, or polynomial division. Okay, so it's up to you, right? If you don't see the 2 by 2 and you're like, I didn't see that, and don't force it. If it doesn't work, it doesn't work. So what I mean by force it is that if I have x squared and I take out the 9 and I get x minus 4, then I can see that these are the same. If they're not the same, then you can't factor this way. If these two aren't matching, then you can't factor using this method. Right? But if they are the same, then you can go x minus 4 comes out, and you're left with x squared minus 9, like that. Okay, so wherever you can, you're going to use whichever factoring method you have. Okay, and it's up to you. Then from here, I want to fully factor this just so that I have a better idea of what the graph looks like. Technically, I don't have to fully factor, but this helps me see that each one of these is order 1. Each one is order 1. That makes it easier for me to be able to picture the graph. Okay, so picturing the graph, we have here, I'm going to draw the graph, and that's about it. And then we're going to just answer the question. So I'm going to do a little sketch of the graph here. I'll do a little graph here. We're going to get a negative 3 and a 3 and a 4. It doesn't matter the spacing. They can literally be all whatever spacing you want. So this will be negative 3, a 3, and a 4. And again, it doesn't matter the spacing. We're just getting the general shape of whether it's above or below the x-axis, right? So for the 0. So then we go order 1, order 1, order 1. Do I need the y-intercept in order to graph this? No. If you want to, the y-intercept, I'll say, is optional. Okay, so let's put that down. Y-intercept is optional. Okay, I don't need to see it. You can put it. You don't have to. If I'm looking for the y-intercept, where would be the easiest place to look for it? Probably this line. But you can also put it here. So 0, 0, 0, and you go negative 4, negative 3 there, and you would still get the same answer, 36. I find that line easiest. You would see the 36, but you can look for it anywhere. Okay? And again, knowing that it's at 36 is useful, but not necessary. So it's optional, so I know that the y is 36. Again, optional, you don't need that at all, but if you want it as a quick check, you can check. Okay? Make sure your graph looks good. So looking at this, I'm going to say that my graph has to go from, okay, degree. Where's the easiest place to look for the degree? Here, here, right? And again, your choice. So you can go 1, 2, 3, degree 3, no matter which way you look, but it's also here. Leading coefficient is positive, and you can look positive, 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 or look here. Again, you don't have to write that. That's for your brain, thinking down from up here, there. So I'm going to start down here, go through each one, okay? No bounces, no anything else. I'm going to go through. Okay, don't care about how high, low, whatever. I just need the general shape. Okay, I know that this is positive 36. Do I need to label? No, you don't, but it's a good check. Sometimes you're like, I got time on my hands. I'll just double check that my graph matches my y-intercept. That's fine. Again, optional. So from this, we went, okay, then I know that I'm looking for greater than 0. So that's why we move it all to one side, because then I'm comparing it to the 0 line. When is it, sorry, less than, I keep doing that. Less than or equal. So don't do the mistake I just said. I want the polynomial less than 0. See, I just almost read the wrong thing. Read it less than or equal to 0, which means I'm looking for where is it below the x-axis, not above. So we're going to say right here and here. That makes sense? So you're looking for where is it below the x-axis. Don't make the mistake I just made. Right. Okay, so we got that lovely thing. Then, what else? Oh, just answer the question. That's it. So we just want to answer the question. So from here, I'm going to write the interval and the set notation. Again, if we don't say what type, I prefer the interval. Okay, and if not, read the question and then answer the way the question wants. But let's practice both, right? Let's just keep practicing both until we get really, really sick of it. All right, so let's practice both. I'm going to do interval. Okay, so for my interval notation, I've got less than, and again, is it equal to or not equal to? Go back to this here, right, all the way through, right? So this is going to be equal to. Okay, so I look there and I go equal. I'm going to highlight that one more time. So I look there and I say equal. And I look here right at the beginning of the question to see if it's less than or equal or less than. Okay, so then that tells me on my answer here, right, that it's going to be square brackets, equal to, that sort of thing. So I look from the question. So since it's equal, I know that this is going to be x is an element of, you can see the pink, right, element of, and we're going to go from the negative 3 to the left, so negative infinity to negative 3 square. Okay, so from the original inequality, you're telling yourself it's square. Okay, you can use the word or the symbol. Or use or. Okay, so I don't care if you use or the symbol, up to you. I'm going to go back and forth. So in the notes, I'm going to use or, I'll use the symbol, back and forth. Okay, so up to you. So I'll just highlight that. So you can use or the symbol, it's up to you. And then it's going to go between 3 and 4, and that's equal to, because we look back here, equal. So it'll be square on the 3, square on the 4. Done. Okay, practicing set. Okay, I know it's redundant. It's just that we're going to practice both so that you're never scared of either. So for my set notation, we're going to go from x is an element of real, and we're going to say x is less than or equal to negative 3, or, so you can use or the symbol. So this one I'll use the symbol, next one I'll use or, right, and go back and forth. We never use the word and, because if we say between negative 3 and 4, that's end. But why would I use the word and? I would just put it between, 3 and 4. I wouldn't use the word and, I just put it between 3 and 4. That is x is greater than or equal to 3 and less than or equal to 4. Right? So, end. That is my end, but I'm not going to use the word end. All right, let's do that again. Few more times, and I'm just kind of going through slight variations in the question, right? So that's kind of a straightforward one. Let's do another one. And then I'm just doing kind of nuances and little variations that we can do in the question. So the next one, questions with that, we're okay. All right, so this one here, same first step. I'm going to bring it over to one side so I can compare it to 0. Right, so over here, there, and we're going to do this. So we're going to go 2x cubed minus x cubed, so x cubed, that, minus x squared, 2x. This is negative 10 plus 2, so minus 8. Okay. I can't factor it 2 by 2. I don't see anything common. I'm going to have to use factor theorem. Okay, so factor theorem, I'm going to tell you, I already checked this, and I found that f at 2 works. Right, and you would look for your multiples of 8. Right, so f at 2 did get me 0, so then I'm going to go therefore x minus 2 is a factor. Okay. And we're going to do synthetic. So I'm going to just grab this guy and go 1, negative 1, 2, negative 8. And this is 2. And we're just going to grab this. It's 1. 2 times 1 is 2. Add it. It'll be 1. 2 times 2 is 2. Add it. It'll be 4. 2 times 4 is 8. Add it. You get 0, which is good. Okay, and then this gives me x squared plus x plus 4. Can I factor that anymore? No. So then I have, this is my answer in factored form, right? So I have here x minus 2, and then x squared plus x plus 4, and I'm looking for when that's greater than 0. But this is a trinomial. So even though it can't factor, so this is different than last chapter. Last chapter we were factoring, fully factor. That is fully factored. But when we're going to go graph it, technically I can give you something here, right, that actually has roots, right? And we could look for, so when we ask you to solve it to find the roots, you would set each one of these equal to 0. So this would be, you get x minus 2 equals 0, so x gets you 2. You can do that faster. This, you're also going to set that equal to 0 to find the roots. It's what we did last chapter, right? We didn't have a lot of the trinomials that ended up with an answer, but you have to check it. Okay, you do have to check it. Last chapter, we were pretty much just trying to get you to factor. But this one, we have to check it. Don't assume that it's a trinomial so it isn't factorable. So we're going to have to go ahead and do here. We're going to go x equals, and we go negative b plus or minus b squared, square root b squared minus 4ac, all over 2a. So we do have to check to see, yes, what I do.
Can we just do the discriminant?
Yeah, so just say discriminant and then show that it doesn't work, yeah. Right, so once it's negative, yeah. So the question was, can you use the discriminant? Yes, remember in grade 11 we showed you if the discriminant is less than 0, no roots. Right, so if it's greater than 0, you'll get 2 roots. If it's less than 0, no roots. Equals 0, you get 1 root. Yeah, so you can check the discriminant and then do that and check there. When I check it though, so what do we get? Negative 1 plus or minus, we get 1 squared 4 times 1 times 4. Yep, so for sure. Yep, so if you check the discriminant, say it's negative, then you've got no more roots, which is what happens here. So we get negative, I got negative 15. Yeah, so as soon as you see that, you go, oh yeah. So because the discriminant, right, the discriminant we taught you last year in grade 11 was inside of the square root symbol here. So because the discriminant is negative, then therefore no solution or no roots. Okay, but if it is positive, then yeah, you'll have to find the 2 roots. If it's 0, you'll get 1 more root, but then we probably should have been able to factor it, right? So, okay, so please do check it. You might get an answer out of that. I didn't, which means that when I graph this guy, right? So I did take each one, set it equal to 0, just like we did before. When I graph this, I only get one x-intercept. Make sure you do label your x-intercept, though. Some people are just drawing dots, and they're not labeling it at all. And their graph is actually backwards, because you're thinking this is a -2 and stuff. So it's actually impossible for me to read when it's not labeled, right? So if you just do dots, I actually don't know what those dots mean, because people are making positive, negative mistakes. So it's not a useful graph at all without the x-intercepts labeled. Because I don't know what you're saying, and you're not really giving much information. So do please label that. Y-intercept is optional. I don't care about that one in terms of this. You can use it to check. It's optional. But the X, you have to tell me what the values are. People were, last chapter, giving me nothing, and then they actually have their 3 to the left or to the right of their 4, right? So I'm like, I think you, yeah, so that's why. It's not readable without the X-intercepts. So 2, and then it's going to be degree. Okay, look at the degree. You can go back here, right, where you brought it to one side, or you can go back here. Its degree is 3, and it's positive, which we know it's positive, so it's going to be a positive leading coefficient, right? So it'll be like this. So again, you don't have to do this. This part is, right, just your brain thinking that, but it heads down here and it goes up here. If you want the optional y-intercept, you could look here, and it would be what? So, -8. Yeah, right away. And here, 0, 0, 0, -2 times -8. So you know it's down here. Again, I don't know what's happening. I just know it's linear through here. And then who knows what's happening here? Question mark, who cares? I just want to know when it's above or below the x-axis. So this diagram is even less accurate than the one we did in chapter 3. I don't actually want you to try to explain anything here. I just need it goes through, which means I need to know it's above here and it's below there. I don't need the y-intercept, right? So I'm not going to mark that part. I just need this labeled and then that. Yes?
Yes, since it's a degree of 3, would you mark it correct if we did like a cubic shape?
Doesn't matter. I don't care about the shape. So that's why I use even less time on the shape of it. Don't be like, well, I'm trying to be accurate. No. Right? I want above or below the x-axis. So this is less accurate than the other one. I'm not looking for cubic shape, not even when it is cubic. So I'll show you in the next one, if you drew the cubic, if you didn't draw the cubic, I just need above and below. So this diagram I'm going to mark even easier. I want to see above and below. And the y-intercept doesn't have to be there. Yeah?
So if it's like a pretty simple one like this one, can I just like not draw the graph?
If it says by graphing, so if I say solve, you don't have to. If we say solve by graphing, I need the sketch of a graphing. Yeah, but I'll mark the graph easier, right? So you don't have to be like, oh, I didn't include the y-intercept, right? So that's optional. I didn't make it look perfectly cubic. Don't care. I want above and below, right? So in this time, solve by graphing means I need above and below. If it says solve, yep, you don't have to do that at all. You just go, well, I know there's only one time, and I know this part, so I need no graph. Yeah. So if this question says solve, technically you don't have to graph. If the question says solve by graphing, I need this, but then this can be a little bit less accurate than the other graphs you were doing. The other ones I was marking the graph for the graph, right? So here, above and below, I'm like, something's happening, but I know it's below. Does that make sense? Okay. So here, for me, I've got, an answer. So then my answer is, where is the polynomial greater than 0? So that would be here. Greater than 0. Okay, greater than 0. And then we're just going to answer that. So again, an interval. Okay, in interval notation, that would be x is going from 2 round to infinity. And we know where to get the round from. We know because the original question was greater than but not equal. Right? So if that's not equal, it'll be round on the 2. Okay, and then for set notation, you would say x is an element of real, and then x is greater than 2 but not equal. Okay, questions with that?